In this lesson, we're going to cover some of the basics regarding configuring BGP on our Arista switches. We'll assume you have some experience with BGP, and so we won't dive into all the RFCs and standards. But know that Arista's implementation of BGP is based upon industry standard. And as the standard dictates, BGP neighbors are configured and leverage TCP, specifically TCP port 179, to establish neighbor relationships. BGP is an exterior gateway protocol and can be run solely within your organization or as a protocol to communicate to other organizations such as service providers or business partners. If a BGP neighbor relationship is between two devices that reside in the same AS or autonomous system, then those devices are said to be running iBGP or internal BGP. If a BGP neighbor relationship is between two devices that reside in different ASs, then those devices are said to be running external BGP or eBGP. Arista switches support running a single instance of BGP, simultaneously running iBGP and eBGP, multi-protocol BGP, and BGP confederations. To verify the most recent features of Arista's BGP implementation, be sure to check the Arista Configuration Guide and the Arista EOS Central website. For our BGP lessons, we'll leverage a lab that has 5 Arista switches in it. And as you can see in this lab, we're running AS numbers 65001 through 65005. Each BGP speaking router will be talking eBGP to its neighboring device. I've configured the BGP on all the switches except switch 1. So as we configure switch 1, we'll be able to verify our changes, see BGP get established, and look at the routing tables produced by our BGP implementation. To get started on switch 1, let's issue the command show IP interface brief. This listing provides us all of our IP addressed interfaces on this switch. IP routing is not enabled by default. So if this is a new switch, you'll need to turn on IP routing. And we do that with the command config, enter, and then simply IP space routing, enter. And then now we can configure our BGP. And we'll do that with the command router space BGP space and then question mark. And here's where we'll enter our AS numbers. Recall that RFC 6996 outlines the use of private AS numbers from 64,512 to 65,534. In this lab, we're using 65,001 to 65,005. So on switch 1, we'll use 65,001, enter. And now we're in router BGP configuration mode. The next step in basic BGP configuration is to configure our BGP neighbors. There are 2 types of neighbor configuration. We can use the static method and then the dynamic method. For the static BGP neighbor configuration, we simply use the neighbor statement along with the neighbor's IP address and AS number. For our lab on switch 1, that's going to be neighbor space 172.16.200.2 space and then the keyword remote-as and then the AS number of the neighbor, in this case 65,003. And the other neighbor for switch 1 is neighbor 172.16.200.6 with the remote-as of 65,004. We can verify our configuration with the command show run section router BGP, enter. And here we can see our router BGP 65,001 and our neighbor statements. And note that by default, the Arista switch added a maximum -routes command, where the maximum routes accepted from either one of these neighbors is 12,000. And because I've already configured the other switches, we should have BGP neighbors established. So if we issue the command show IP space BGP space summary and hit enter, we can see that we have both of our neighbors established. Established indicates that we successfully negotiated the BGP relationship and have established our BGP TCP session between the devices. In this output, you can see each neighbor's IP address, BGP version, AS number, amount of messages sent and received, how long we've been in the current state, the actual state, and finally the prefix count. If we were running in VRFs, then the same command would be used, but with the added keyword of VRF and the VRF name at the end. Let's look to see if we're receiving any routes and have put them into our routing table. First, we can use the command show IP space BGP and hit enter. And here in this output, we see a listing of all the BGP routes that we've received from our neighbors. If you look to the flags listed on the left-hand side of the output, you can see which ones were selected to be placed in our routing table. Another nice piece of information in the output of this command is on the far right, we can see the AS path information for each route. Within the AS path, the origin AS is in the far right of the list, and working our way left, we can see which ASs the announcement has passed through. Among the many variables used to select the best route, the shortest AS path is one of the criteria. For instance, if we look at the first network in the output, 172.16.0.2, we can see that we learned that network via two different AS paths. Both originate at AS 65002 here in this AS path list, as well as here in this AS path list. And 65002 is switched to, and that's where 172.16.0.2/32 originates, as it is the IP address assigned to interface loopback 0 of that switch. Looking on the left, we can see the greater than sign is listed next to the one with the shortest AS path. So that's the one we've elected to put into our routing table. And we can see the next hop is 172.16.200.6. And if we look at our fib, or the actual IP routing table, with the show IP route command, or to specifically focus on BGP, we can use the command show IP route BGP, enter, and we can see the one placed in the routing table is the path with the next hop of 172.16.200.6. Using the command show IP BGP 172.16.0.2 is another way to look at the information we have for this route. The output shows us all the paths for reaching that network, and we can look for the keyword best to know which one has been chosen as the best route and therefore will be placed in the routing table. As you can see, Arista switches use the industry standard you've come to expect when working with BGP, and now we have a basic configuration of BGP up and running in our lab environment.